Derivatives of exponential functions, an important question from test point of view. I am Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. In this video, we'll take up a test question based on derivatives of exponential functions. I have provided the formula for you. F of x is equal to e to the power of x, then the derivative is exactly same, the y value of that function. If f of x is equal to e to the power of g of x, in that case, the derivative will be e to the power of x times the derivative of g of x. Apply the chain rule. Perfect. Now, we have a test question here. Let me call this as our question number 1. Find all points at which the tangent to the curve y equals to x squared e to the power of minus x is horizontal. I would like you to pause the video, answer this question, and then look into my suggestions. We'll provide a complete solution of this in this video. In case you really want to learn from me, you can always send an email to globalmathinstitute@gmail.com or contact us on the website. Now, question here is to find all points at which the tangent to the curve y equals to x squared e to the power of minus x is horizontal. It really means what? It means horizontal tangent means derivative is 0. Keeping that in mind, we can easily solve this question. So let's begin by writing this equation, which is y equals to x squared e to the power of minus x. Now we can apply the product rule, right? So if you have a function f of x which is equal to product of two functions u of x times v of x, in that case, what is the derivative of this particular function? Well, the derivative is the derivative of the first function times the second plus first function times derivative of the second function. So we'll apply the same rule here. So the derivative of this particular function will be derivative of the first function, which is 2x, times the second, which is e to the power of minus x, plus the first function times the derivative of the second, which is e to the power of minus x times minus 1. Why minus 1? Because the derivative of minus x is minus 1. Following this particular definition, e to the power of g of x will be derivative e to the power of x times derivative of g of x, correct? So that becomes the derivative. Let's simplify this. So we have 2x e to the power of minus x, and that is minus, and we have x squared e to the power of minus x. E to the power of minus x can be taken as common along with x. So we can write this as x e to the power of minus x, and within the brackets we get 2 minus x squared. So that becomes the derivative of this function.
After attending university. The winner of this year's Certificate of Achievement Schulich Leader Award is anil.anilkhandelwal.
Great. Our student Akshat gets highest marks and the most prestigious Schulich Leader Award. You can be there. Join our classes and excel.
So now you know the derivative. Can you pause the video at this stage and find all points at which the tangent to this curve is horizontal. Means what? Means that we have to equate this thing to 0 and find the value of x. That is what we mean when we say horizontal tangent. Clear? So let's find out these points on the next page. So we have the derivative, which is x times. So let me write down the derivative of this function. Y prime equals to x times, what did we get? 2 minus x squared, I think, right? E to the power of minus x, we can write it in the denominator, right? Correct? So this e to the power of minus x, I'm writing in the denominator. Let me rewrite it here, which is x times 2 minus x squared over e to the power of x. Clear? Okay. So x times 2 minus x squared over e to the power of x, we can equate this to 0 for horizontal tangents. That means the numerator should be 0. So numerator is what? Numerator is x times 2 minus x squared. Let us equate this to 0. Now it really means that x is equal to 0, or 2 minus x squared equals to 0 means x is equal to plus minus square root 2. Clear? So these are the points where the derivative could be 0, right? Now if you look at this particular function, the domain is all real numbers for this, correct? And therefore, all will be possible solutions. Now remember, we want all points. When we say points, we need to give the y values also, right? So let us calculate the y values now. So if x equals to 0, then y equals to 0, correct? When I substitute 0 here. Now, what happens when, so that means I get a coordinate point 0, 0. Perfect. Now, if I substitute x equals to square root 2, in that case, y will be equal to what? So, square root 2 square, right, times e to the power of minus square root 2, correct? Which is 2 over e to the power of square root 2, right? And if I write this as minus 2, so we have x equals to minus square root 2, then I have y equals to minus square root 2 square, right? And we have, but both should be in the bracket. You get the idea? And this value will be e to the power of minus will give me square root. Is that clear to you? Perfect. So we get a value here also. So we have three different points. One is 0, 0. The other one is at square root 2x value. We get 2 over e to the power of square root 2, right? And the third one is at minus square root 2, which is 2 times, because this will become positive, right? So 2 times e to the power of square root 2. Does it make sense? So these are the three coordinate points. Perfect. So let me read out the answer here. We have points as 0, 0. That is first point. The second point is at, let's say if we take positive square root 2. In that case, we get the y value as 2 over e to the power of square root 2. And if we take the negative square root, then it is 2 times e to the power of square root, correct? So these are the 3 points on this particular curve where we have horizontal tangent. Is this clear to you? Perfect. So that is how we are going to answer this particular question, right? I hope this solution is absolutely clear. Feel free to write your comment, share your views. In case you like and subscribe to my videos, that'd be great. And if you want to learn from me, you can always send an email at the address given or contact us on the website. Thanks for your time and all the best.